first presentation is Reducing Downtime by Creating the Right Maintenance Strategy for Your Company. It will be presented by Miguel Ramos, co-founder and COO of Limble CMMS. During his discussion, Miguel will speak about how to identify your largest contributors to downtime and how to create a strategy to make the biggest impact to reducing downtime with limited resources. Miguel is the co-founder of Limble CMMS, a maintenance management software. He started his career as a technician in a fabrication shop that built production equipment for a variety of industries. Over time, he became more involved with the entire production process, designing products, creating production lines, managing product teams, and maintaining product equipment. Miguel also has a master's degree in manufacturing, ergonomics, and safety design. After Miguel has finished his presentations, we'll open the virtual floor for any questions. If you have any questions now or after the presentation, or during or after the presentation, post them in the Zoom questions box below. Over to you, Miguel.
Oh, great. Thank you so much, Mario. Okay, well, let me share my screen here. And as Mario said, the title of the presentation today is Reducing Downtime by Creating the Right Maintenance Strategy. Now, I would like every participant to pull out a piece of paper because we're going to pull out a few things out of this presentation to help you. My goal is that I want every attendee to have a plan to improve their downtime in some way by the end of this presentation. And the other big goal I have is I want to teach a repeatable process because I really believe that improving downtime happens over multiple steps. And so today is just the first of those steps, and you can use the same process as you continue to improve. So let's get into how I see most companies go about improving their downtime. First off, they start with Google, and they say, Google, how do you reduce manufacturing downtime? And Google is going to give you a lot of fun results. They're going to tell you about Industry 4.0 and sensors and vibrational analysis and all these really fancy things that you can do. So what that means is that the maintenance team puts together a project proposal for Industry 4.0, sensors and vibrational analysis, just like Google said. And what that means is they need a project lead, they need money, they need to create a scope, outside experts perhaps need to be involved, and it can take months of work to accomplish a project like this. Well, after many months and muchos dólares later, this is typically what I see. An over-engineered fork, or in other words, something that is very cool, very well designed, very fancy, but is it really that much better? And this is a common theme. In fact, when in preparation for this, I reached out to a few customers, or for a few companies, I should say, just to ask them kind of like their original approaches. And this is definitely one that came up over and over again. And I didn't see anybody really have a lot of success with this approach. And I think it's because it doesn't have anything to do with the fact that Industry 4.0 or sensors or vibrational analysis are bad ideas. In fact, there's some other presenters today that are going to be talking about some of these topics. And I think that's great. I think it's really important to learn about them. It's not that any one of these things are bad in themselves. It's just that the approach was wrong. As my grandfather used to say, it's putting the cart before the horse. Or for you millennials out there, I don't know the best millennial equivalent, maybe it's like flushing the toilet before you use it. And so we need to make sure that we take the right approach. And I think that the original question was wrong. We should have never asked Google. It wasn't specific to our needs. Instead, we need, and the other big issue with this, of course, is that it's not iterative. You just ask one question and you create a big project on it. And it's really important to learn as we go. So there is a better approach, and that's what I want to talk about today. And I think that with this approach, you're going to see faster results, it's going to be less work, and you're going to see bigger benefits. So let's talk about this approach, and it's the lean methodology or continuous improvement. I'm sure many of you have heard this, the Toyota method. We're going to apply some of those same principles to maintenance and manufacturing, and of course, to reducing downtime. So before we get into that, though, we first need to understand what is going on with our facilities and our production equipment. So if you have your pen and paper out, why don't you go ahead and write down some of the answers to this question. First off, what is causing the most downtime? Which machines are causing the most downtime? How often is this happening? How long is the downtime happening for? And then another big one is what processes or systems are making the downtime worse? A few common examples that I see are the downtime alert method. Sometimes the maintenance team doesn't even know until it's been happening for a while. Another process or system that could definitely be improved for most companies is having replacement parts on hand. If you don't have the right replacement parts on hand, you are going to have more downtime because you don't have what you need. You're going to have to send somebody to go get that while the machines are waiting. Another big process or system that can cause problems is just the coordination between manufacturing and maintenance. So that way they can do the right maintenance schedules and work together. Now, with all this being said, you may have some answers to some of these questions, but if you don't have an answer to them, that's okay. Just write a little question mark next to it. We can get more into that. So now that we've had a chance for you to kind of think about what is causing this downtime, where it's coming from, I want to talk about what if you don't know the answers? What if you have question marks next to all of these? And first off, that's totally okay. That's a normal place to start. So one option that you can do is you can just go off memory. And I see a lot of companies start this way. And if you're going to go off memory, I would definitely recommend asking team members and try to get a variety of ideas because we all have our own bias. In fact, that's kind of the downside to just going off of these, trying to get these answers with memory, as you might not always remember. It's a little bit error prone. You might have some indecision because there's so many things that you need to do. And then there's always the bias of, hey, this is my favorite project or the most important machine to me, or there's that recency bias of, oh, this is the last thing that broke, so that's the thing that we should fix. So there is another way if you don't just want to go off of memory. And this is what I really recommend for pretty much every company that's running maintenance, is that you consider getting a CMMS or some other form of tracking all of this data. Now, CMMS, of course, is kind of what it's designed for. The software, this group of softwares or class of softwares, it's going to allow you to see the causes and downtime trends. You're going to be able to see which machines have the most downtime, break down frequencies. It's going to help you improve the processes that we talked about, like having those downtime alerts come over automatically, having your parts replacement on hand and know what your inventories look like. It also helps with communication between teams. So that's why I think the CMMS can be so important to answering these questions. Now, let's assume that you know the details of some of these answers. One thing that I think is really great is that I've never seen a customer not have these details and not know exactly what problems need to be fixed. And that's what's really important about having the CMMS is just from looking at the data, you're going to start seeing some solutions and it's going to start becoming obvious. The only problem with those is that there's typically a long list of what to improve. And so where do you start? This is where I want to talk a little bit about the lean methodology and how this is going to help us, because it helps us understand our problems and we create a strategic plan and then we make little improvements. And what I like about that is those little improvements can really lead to big results. So to be strategic, I like to use the Pareto principle. So let's actually do a little history lesson. This is Vilfredo Pareto, and I love that his name rhymes. It's kind of like the Shaquille O'Neal of his day. And he noticed something interesting in his garden. He noticed that of the peas that came out of his garden, 20% of the pea plants were producing 80% of peas. He also noticed that when it came to the land ownership where he lived, is that 20% of the people owned 80% of the land. And so this principle that happens so much in nature was named after him. And you've probably seen this, that, you know, maybe 20% of your children cause 80% of your gray hairs, or maybe at work, 20% of the people do 80% of the work. Or in the case of downtime, it's usually 20% of the machines cause 80% of the downtime. So what that means is that if you can find a way to put in 20% of the effort and get 80% of the result, that is where we want to focus our attention. So I really think that this is something we can do as we think about maintenance and downtime. We typically can determine what that 20% and 80% is. So if you remember that original thing that we talked about with these plants going from, full on industry 4.0, everything automated, everything has a sensor. I typically see that that's 100% of the effort, and it usually just leads to more problems. And that's why this 80-20%, 80-20 rule can make a big difference. So the overall principle here is, your biggest problems. You know that you can partially solve the problem. And I think that's really important to think about that. We don't need to solve every problem today. We only want to solve the ones that we can have the biggest impact in. Again, how can you do 20% of the effort for 80% of those results? So since the goal today is to have every attendee to have a plan to improve their maintenance system and to teach a repeatable process, then we're going to talk about a few examples that hopefully will help spark some ideas for you. So the first one is the company that shall not be named. This one came to me a little while ago and they said, hey, we really want to purchase some sensors. Specifically, they wanted to do vibration sensors and temperature sensors. And they needed about $3,000 worth of sensors. And they didn't know how to connect the sensors. So they were going to hire a specialist to come in and connect those. And their plan was to monitor readings on all their equipment. And that was their plan to reduce their downtime. And when I asked them what led them to this approach, they said, well, we're doing an MBA. And in one of our classes, we heard that this is the best process for this thing. They had some case study they were going off of. And I said, that's great. That's a great start. But let me ask you a few more questions to understand your situation. I asked, are these sensors going to be placed on your equipment that gets break down the most? And they said, we don't know because we don't know which equipment is breaking down the most. And then my next question was, if you could see the vibration amplitude and frequencies on your equipment, would you know if that's normal or high? And they said they had no idea what that would mean. Like they wouldn't even know how to understand what that data is giving them. And lastly, I asked, you have preventative maintenance schedules for your equipment to begin with? And they said, no, they have actually never done any preventative maintenance. And then I had to tell them, guys, I don't think that what you need is sensors. I think that there's some really foundational things that you need first. And so we spent some time analyzing their equipment and understanding where their biggest needs were. And fortunately, they did have a CMMS. And so we were able to determine that the most common equipment for breakdown was a big printing press that they had. And that was the first step. And we realized that after that, there was no preventative maintenance, and we knew exactly what problems were happening. So that is where they ended up starting. So I want to give you a different example. And this is an example of where a company did something that I thought was a really good approach. First off, this is Joe from Wisconsin Cheese. He's in Wisconsin, believe it or not, doing cheese up there. And he had a situation that he came to us and he said, hey guys, I've started with our preventative maintenance. My team's using the CMMS really well now, but I'm still having downtime issues and I don't really know what to do next. And so he said, well, what's most important to you? And he said, I want to reduce downtime. But in order for me to reduce downtime, I really would have to fix the whole plant because I see hundreds of breakdowns all the time and there's just too many for me to even fix. In fact, we'd probably have to fix replace every machine in the whole plant in order to reduce our downtime. And this is kind of the problem with memory, is it's not Joe's fault. He sees so many issues every day that he's thinking everything is bad. Like there isn't a single cause to this downtime that I can really focus on to improve. So we said, hey, that's okay, Joe, because since you've been using your CMMS so well, let's actually apply the Pareto principle here. So the first thing we did is we ordered all of his pieces of equipment in order from the ones that had the most downtime to the least downtime. And I want to show you that there's a really clear trend here. It turns out that his downtime was coming from his feta machines. Those were all at the top. And when we showed this to him, he looked at us and he said, I had no idea. The feta machines, I don't know that they break down, but there's so many other pieces of equipment that break down here. And we were able to determine, well, even though there's a lot, these are the highest breakdown machines. So once we knew that those were the highest breakdown machines, we listed out. Oh yeah, and I forgot to say, it just happened to be, again, the Pareto principle, it's crazy, it pops up everywhere. about 80% of his downtime was coming from those same machines. So we listed all of the tasks that he had completed on these machines recently. And we noticed a few trends. One of them is that there seemed to be this issue with the temperature. And there was cleaning the heaters, there was low temperature alarms. And when we showed this to him, I said, look, well, I shouldn't say it was one of my team members was the one having this conversation, Dan. So Dan said, I don't know your equipment well enough. What does that mean that you keep having these temperature issues? And Joe immediately knew the solution because he knows the equipment. And he said, I know exactly what's causing these heater problems. Really, it's just time for me to replace the heaters. They go out over time, and apparently we're spending a lot of time cleaning them and hitting these low temp alarms. But if we were to get the new heater that's out, we're not going to have those issues. Great. The next thing that we noticed is there were a lot of these mold adjustments. And again, we didn't know what that meant, but Joe knew what that meant. And he said, oh, I've had to adjust those molds before. He said it's the clamp that holds that mold. It's not very secure. It tends to drift. It doesn't have like a really solid connection. And he said, I think that I could improve the locking mechanism pretty easily on that. And all I would have to do is go down to the machine shop and get this little piece made, and we can really lock those down tight. And we said, great, then it sounds like you have a great plan. And what that means is that since 80% of the downtime came from those two issues on the FETA machines, so we have 80% of our downtime came from the FETA machines, and 80% of that downtime came from two issues, that he was able to solve 64% of his downtime. It only took 5 minutes to identify the solution when we pulled up that information from his CMMS. And he realized that it only took 4 days of work to go to the machine shop and buy these new heaters and install them. And that was going to prevent 64% of his downtime in his entire manufacturing facility. And one thing that I think is really great about this story is this is a really typical thing that we see. If you notice, he didn't use sensors, he didn't use Industry 4.0 or other things. What he did is he saw the problem and he knew the solution. Now that solution could have been sensors, it could have been Industry 4.0 type things, but that wasn't the thing that was causing the biggest problem for him. So for those of you who are thinking about your own manufacturing facility, you can ask yourself, what is it that is causing the biggest problem for me? And that's where you're going to be able to use that lean methodology. So kind of a few conclusions to draw here is data equals money. I think that that's really important. Joe wouldn't have known what to do if he didn't have the data. And one phrase that we like to say around here is you can't improve what you can't measure. And that's what Joe was able to do, is he was able to measure those problems. So that concludes the end of my training, and I hope this was helpful. I want to make sure that we have plenty of time for Q&A, because what's most important to me is that we answer your questions, because this session is for you to help you come up with your own strategies and present your own problems.
All right, thank you, Miguel, for a very informative session and answering the oh, sorry, went up too high. Sorry about that. Lots of good. We will now move on to our question and answer part of the session. If anyone has any questions for Miguel, don't forget to post them in the Zoom questions tab below. Our first question would be, what should we look for in a CMMS?
That's a great question. I think the first thing is you need to look for one that your team is going to use. You're not going to get any use out of it unless your team is actually using it. And the way that I've seen companies go about this is they get a free trial and they test it out. They'll get it in the hands of their team. They'll say, hey, download this app on your phone. They'll get it on their computers and have them actually try testing it out. So I think that's the most important thing you can do to actually find if that CMMS is going to work for you. And then the other things that I would say is, since you're already in that free trial, determine the things that are most important. Downtime, since we're talking about that today, is really important. So if you have an opportunity to actually test out the downtime features and make sure they work for your team, that's going to give you a huge leg up to knowing if that's going to be a great fit for your company.
And just sort of jumping off of that, what would you say are some of the more important features to have in a CMMS?
That's great. One thing that I think is interesting about CMMS is that overall, they typically have the same modules, the same underlying functionalities. And it really comes down to how they do those. So for example, almost all CMMSs have the ability to create work requests, to manage work tasks, to create your PM schedules, and track cost and create reports and those things. So if they all have some of those same things, what's important is to start testing out how your team is able to use them and if it becomes intuitive to use. Another thing to keep in mind is that system going to grow with you? Over time, you're going to find more and more ways to use it. Typically, companies start using a CMMS with just a few features, but then they end up adding more and more features that they want to use. So think about the long term and say, as we end up advancing, maybe you're going to add sensors, maybe you're going to add other things. Is this system going to allow us to add in those other features that we're going to need as we grow?
All right, got a couple questions from the audience. Let's go with, there are different versions of CMMS like IBM's, SAP, Oracle. How do you go about choosing among the many? They seem to be doing the same thing with different levels of effectiveness.
Yeah, that's a great question. And you're right that there are things like SAP and IBM. One thing that I see often with SAP and IBM is that there's some other part of the company that's already using an SAP product. And so it makes sense to connect those in. For example, SAP has their SAP PM, which is basically a CMMS add-on to SAP. And one thing I would say about that is if you're going to consider that, SAP is built to be a very robust system, but it definitely is more complex to use. I haven't met too many people that have said that SAP is super intuitive. And keep in mind the people that are going to be using this. Usually maintenance technicians are people who are very technical. They love to get into the machinery, but they're not necessarily interested in learning the ins and outs of the software that could take a long time to train on. They typically want to move quickly and they want to be able to pull up their app and say, hey, I know exactly what's going on here. So even if your company is using SAP, for example, there are systems out there that connect into SAP, and that makes it a lot easier to be able to use a CMMS that's been specifically designed to be a CMMS and simple to use, and have that communicate the necessary data to SAP. And I've seen the same thing with IBM's product. Again, it's one of those very robust systems, but a little bit more difficult to use for most companies. And I want to be fair to them because I think that they do have a great product, but for most companies, ease of use seems to be just so key for a system like this and the team that's going to be involved.
All right, another question that's come in. I've been reading about reactive, preventative, and now there's predictive maintenance, where they use AI to have historical data determine when something might fail. Is this something that you're looking into?
Yes, that's a great question. So let's kind of define those three strategies. So there's the reactive, preventative, and predictive. So reactive is where most companies start out. When there's a problem, they go find it and fix it. And the problem with that is that you will spend a lot less money preventing a problem than you will to fix a problem. And just a quick example would be if you forget to put oil in your car, that's reactive maintenance. And typically replacing a motor is anywhere from 50 to 100 times more expensive than it is to just put the oil in the car. So we always want to move away from reactive maintenance. Preventive maintenance is when you have preventative schedules. These are preventative maintenance schedules like your typical PMs. You're replacing filters, you're cleaning the machine, and different things that would prevent the wear and the breakdowns from happening. Predictive maintenance, I should say, you typically need to have some sort of sensor involved. And that's because it's going to measure some different, you could call them almost health metrics of the machine. And when you do that, you can hopefully notice when there's going to be an issue before it happens. An example of that would be that the machine starts vibrating to the point that you're saying, okay, there's probably an issue. Maybe a belt is wearing down or something. For most pieces of equipment, that is something that you need to understand the piece of equipment pretty well. And this is where the AI portion comes in, where you have some sort of machine learning or something else that you can understand where that machine is commonly having issues and will commonly break. And so it can tell you that before it happens. And that is 100% something that we are working on. And I don't want to get too deep into that because there's some cool things coming up in the future, but I don't want to announce them before we're ready for that. However, I would say that it's very few companies that I feel like really need that predictive maintenance. This is the big hot topic in maintenance right now, but it's one of those cherries on top when I still see people really need to build the base of the cake. And so if you are in a situation where you're trying to figure out what's next, you want to take this methodology we talked about today. Where are the biggest problems coming from? And if it turns out that doing some predictive maintenance work is the next step, that's definitely what you should be doing. But most companies I see are finding that there's definitely things they can be doing that are a lot easier to do to get an even larger result.
All right, thank you. Our next question: how should reliability engineering and maintenance teams talk to each other with the CMS system front and center to brainstorm why an asset is down often and do a reliability analysis?
Oh, that's a great question. So I'm glad that you have all three of those teams at your company. Most companies don't have that. So that's, first off, you're already off to a good start. Second off is it's really important to have great communication between those teams. I think it's important to have a regular meeting where you can, and then have a really defined objective for each one of those meetings. And this is where you can use the exact same strategy we talked about today. A common strategy for that meeting is, I would say, today we're going to talk about downtime. And so we're going to do an analysis as a team on the most common pieces of equipment for downtime. And then from there, you're going to be able to see where the most common problems are for those same pieces of equipment. That's typically a good structure. And if all three of you are in the room, you're going to be able to collaborate and think about how do we work together to prevent this problem. And one thing that's nice about having a reliability engineer and manufacturing and maintenance all in the same room is that you're going to come at it from different perspectives and have more creative solutions. I actually have an example of that, if that's okay if I share.
Yeah, go ahead.
So this was back in my days of running a manufacturing line, and there was a manufacturing line that was having a particular problem with the production. And fortunately, in talking with the team that was working on it, they understood pretty well that there was one specific machine that was causing problems, and it was a gluing machine. For those of you who have worked with gluing processes, they're always dirty, they're always difficult in my experience. And the gluing machine, there had to be this fixture to hold these little tiny pieces together, and those pieces needed to be glued. And what was happening is everything was getting glue on it, and it was getting glued shut. And at first, the idea was we just need to train people better. But I got on that and I tried to use that machine, and I still spilled glue the same way like everybody else had. So it wasn't their fault. We needed to change the design. And once we determined that that was the problem, then we were able to say, well, what if instead of making these little tiny articulating features that needed to grab these pieces, what if we made it these large flat pieces that came together in a way that could hold those, hold the production parts in the same way to allow the glue to be applied. And then when glue accumulates, you have these big flat surfaces where you could take a razor blade and just scrape it off in one go. And now it's ready for another round of parts. And so that was the solution that we came up with. And it really came down to, we identified where the biggest bottleneck was, and we determined the cause of that bottleneck, and then the solution just became intuitive at that point.
All right, that's a great example. How do you develop a reliable process in CMMS to separate the MDT to the MTTR?
Oh, that's a great question. So for those of you who are not familiar with these terms, let's talk about them. So you have mean time between failure and mean time to recovery, I believe are the two that are being referred to. So mean time between failure, mean just means average, and then it's the time between failure. And this can be done for a specific machine, or it can be done for all of your equipment as an aggregate. And that mean time between failure, basically whenever that machine breaks down to the point of a downtime event, that is considered a failure in most CMMS programs. And then the other thing to keep in mind is mean time to recovery. So now that that failure has happened, how long does it take to actually get that equipment up and running again so it's working? So that could include the time that it took to report the problem, the time it took to fix the problem, and the time it took to actually get that machine ramped up and running and the manufacturing on it again. So those two things are really important because you see two big issues of it. One, you see how often these problems are happening. And then two, it's a way to measure how long on average it takes. So how severe is this problem when it comes to affecting manufacturing? And one thing I've noticed with these numbers is that they're better used in a relativistic way as opposed to an absolute way. And what I mean by that is you could have mean time between failure for this machine to be 100 hours. So that means that machine runs for 100 hours before you see a breakdown. And this other machine, it could be 300 hours. And that doesn't necessarily mean that this one machine is much better than the other one. What it means is it's good to see those trends over time. Is that trend going up, that we're seeing longer and longer times between breakdowns, or is it going down? And I find that that's a better way to look at it for most companies, because especially if you're looking at an aggregate, as you add more machines, you kind of lose visibility. You add all these other machines, and if you're adding that into the equation, that could be either increasing or decreasing depending on how those machines are running. So if you can break it down to an individual machine basis, that absolute number helps you to see whether it's going up or down. And the two big things to think about there is if you can prevent those breakdowns, you're going to see improved numbers in the mean time between breakdowns. And then the other thing is that you're going to be able to see is if it's taking a long time to recover those machines, what's causing that? Is it that you don't have the right parts on hand? Is it that these breakdowns are really major and maybe you need to have a preventive maintenance schedule so the breakdowns are a lot easier to fix? So those are a couple things to keep in mind. If you have more questions on that, I'd be happy to get deeper into some more specific examples, since this was kind of a large topic and I gave some high-level details there.
All right, I think we got some time for a couple more questions. In your point of view, we have a huge depository of data, but struggle to get insights. How do you take the first step in the data space to go from being reactive all the time to being more proactive?
Great. Well, first off, congratulations on taking the first step of the battle, and that's getting the data. So now that you have this data, this is the pros and cons of data. The pro is that you can make decisions on it, but the con is where do you start? The typical place that I like to start is to list out your assets by either the most downtime or the most money spent or the most time spent on that asset. I don't know what your data looks like, so hopefully you have access to that, to arranging it in some way like that. Depending on your software system, like if it's, for example, when we saw it today with Limble, that's really easy to do. If not, maybe you might need to get somebody in IT involved to say, hey, can you help us like put this into Excel sheet and organize it like this? That might be something that could be helpful. But if you can do that and you can see which assets, which pieces of equipment are contributing the most to downtime, you're going to have a really good start into that. And then if you can break it down further into seeing the types of issues that are related with that downtime, you're going to be able to come up with some conclusions that will help you understand where those issues are and how to fix them.
All right, I think we got time for one more question.
Great.
How do you assign a monetary dollar amount for an asset subassembly that is causing the asset to go down? And the subassembly is a non-stuck item. How do we go about minimizing the impact because we chose not to stock it?
Oh, that is a great question. So there's a few things to think about here. It sounds like if you're running any production on this, then you're going to want to think about how long of downtime is caused from that thing not going down. So let me give you some examples. You're going to want to know how much that machine helps contribute to produce an hour. So for example, let's say that in my case, I came from the medical world, so we would design these drainage catheters for cancer patients. So I would ask myself, how many of these do we produce an hour when that machine is running correctly? And then I would multiply that by how much we sell those for. So in our case, it was, I think those were like $80 catheters. So if I knew that we were running about 300 of those an hour, and I would multiply it by 80, now I know how much money, production money, is coming out of that an hour. And so that's typically the biggest contributor, and that's the best place to start, because if you can show that there's an hour of downtime, and if we were to just do some math here, 80 times 30, or 300, sorry, so that'd be $24,000 an hour of production. So that would be a great one. Another thing that you can do is you can also put into account how long it takes to source that without having that part on hand. So instead of that just being an hour's time to fix, it's also, well, it's the fix time plus the time beforehand where you have to go source that part. Maybe you have to go to a specialty store, maybe you have to order it online. And the numbers add up so quickly that I've rarely seen a situation where it doesn't make sense to keep some inventory of some really necessary parts like the one that you're talking about. And that's usually a no-brainer for somebody in the financial departments to say, yeah, it makes sense to pay this money up front so we have something on hand. And if you can prove to them that you have a system for keeping track of the equipment you have on hand, or the replacement parts that you need, that's going to be really helpful. So one example that you're going to be able to see in most CMMS systems, including Limble, that like we talked about earlier, is that you'll be able to have a list of all the production parts that you need on hand, and you're going to have alerts whenever you run low and you keep a minimum inventory. And this is something else that you can show the people in the financial department to say, hey, we're doing our best to keep our inventories low, so we create a minimum threshold. If we ever completely run out of parts, or if we ever get below that threshold, it lets us know when it's time to buy more. And if we ever completely run out, then we know that we need to increase that minimum threshold, so they can see that you have a system for reducing your inventory needs. Sometimes when you ask somebody in finance to have something on hand, they have a concern that it's going to have a ballooning effect and you always need more and more. But if you can show them, no, we have a process for keeping the minimum amount of parts in stock while allowing us to have the maximum output of production, they're going to quickly see the trade-off and probably be very supportive of that idea.
All right. Thank you very much, Miguel, for the very informative session and answering the great cross-section of questions that have come in from attendees. Thank you again.
You're welcome. Thanks, everyone.